Hello children, let us continue our chapter Matter in Our Surroundings, and this is going to be the second lecture. In the previous lecture we have learned what are the main properties of anything to be called as matter, and now we will see in how many states or forms the matter exists. So, states of matter can be three different states: solids, liquids and gases. So we know that solids are like stone, wood, metals, which are pretty hard and do not change their shape with time or pressure. And then there are liquids like water, milk, fruit juices, everything that we see flowing and that can be easily poured. And then the gases. Gases are all around us in the form of atmosphere, the blanket which covers the entire earth. Now, why the states of matter are so different from each other? You can easily perceive the differences between each state of matter. So, this will become clear as we learn about the properties of individual states of matter. So first, solid. Solids have a definite shape, distinct boundaries and fixed volumes. And we see these attributes in our everyday objects. For example, if you have a table, it has a definite shape. Its boundaries are very distinct. You can even measure them. And it has fixed volume. So, it is not going to grow or shrink with time. Also, it shows negligible compressibility. Solids cannot be compressed easily or to a greater degree. So, we cannot reduce their size by force. For example, if you have been transferred and you have to pack a lot of luggage, so it's not possible for you to compress your furniture because solids cannot be compressed. And then solids are rigid, so they will not easily budge from their place. That is, they are not ready to change their shape even when outside force is applied. They might break or they might change it momentarily and then come back to their original shape, just like in rubber band, but they will not change their shape easily. That's why we call them rigid. And then why are solids like that? Because particles of solids have very strong force of attraction between them. Also, they are very close to each other, so the effect of force of attraction is holding them together. And they remain fixed. The particles of solids remain fixed at their own respective place. With this, we'll be moving on to the next state of matter, which is very interesting, liquid state of matter. So here you can see that the distance between the particles is a little more as compared to the solids. And not only this distance has become more, you will see that the force of attraction is weaker as compared to the solids. So liquids have no fixed shape but have a fixed volume. Okay, so the force of attraction is weaker but not so weak that they totally lose contact of each other. So individual particles are still holding each other and they have a little more distance as compared to the solids, and they do not show any fixed shape. And we all have observed, whether it is water in the river, whether it is the falling water from the spring, or water put in different shapes of glasses or bottles, it takes up that shape. Now, they take up the shape of the container as we discussed, and they are fluid, very easily can change their shape. They cannot retain their shape. So this makes sure that they are not rigid, because rigidity is the property of not changing the shape, and liquids are fluid, so they can change their shape and they can also flow. Solids cannot flow. Now, solid, liquid and gases, all these states can diffuse into liquids. For example, sugar can diffuse into water. Liquids like honey can diffuse into water. Gases like oxygen and CO2 can diffuse into water. So all three states of matter can easily diffuse into liquids. Now, in the liquid state, particles move freely, yes, they have weaker force of attraction between them and have greater space between each other. Yes, that's also true as compared to the particles in the solid state. But how much greater space? Only in comparison to the solid state. And therefore, rate of diffusion of liquids is higher than that of solids. So, let us recall once more how diffusion takes place, children. Diffusion is when the particles of two different kinds of matter get into the space of each other. So, if particles have more space between each other, there are better chances of diffusion taking place, and that's why liquids show better diffusion, better rates of diffusion as compared to the solid state. Now next one, the gaseous state. So here we can see that gases have no fixed shape or volume, and we observe this very frequently that the gas, the same volume or same amount of gas can be stored in a jar, and if the jar is opened, the gas will occupy the entire available volume because there is not enough force between the particles of gases to hold them together. So if they are given a smaller volume to contain themselves, they will remain there, and if the volume is more, they will fill up the entire volume because they have large spaces between each particle and there is almost negligible force of attraction to hold the particles together. And they are highly compressible. How do we compress something? How can we reduce its size? By reducing the distance between the particles. So if there is a large distance, then there are more chances that we can compress that kind of matter. And gases also flow easily. Now particles of gases move about at high speed. Yes, the individual particles not only have very weak force of attraction between each other, but individual particles also have very high kinetic energy, and that's why they always move around with high speed. And gases show the property of diffusing very fast into other gases. This is a very peculiar phenomena, and this is obvious as well because other gases have these same attributes of having more spaces between the particles. So if we are going to diffuse one gas into the other gas, then the diffusion will be very fast, and we have observed this in case of burning of incense stick. So those gases which are produced by the burning of incense stick get easily mixed into the atmospheric gases, and that's how the diffusion takes place very quickly. So once again proving that these attributes hold true to the gaseous state of matter. And why do gases have such properties? Because they have very high kinetic energy particles. The particles are held with almost negligible force of attraction, and there are large spaces between the particles. With this, children, remember the three main attributes that govern the states of matter are going to be shown in the following slide. So we must remember the relative value of those attributes in the states of matter. So let us talk about the distance between the particle. Distance between the particles is highest in the gases and little less in liquids and lowest in the solids. So we can say that solids have their particles held closest to each other. Now force of attraction between the particles will be maximum in solids, a little less in liquids, and minimum in gases. That's why the particles of gases can occupy any space because they are not held by each other, the force of attraction being very less. And then kinetic energy of particles. Gaseous particles contain highest amount of kinetic energy, and that's why they move around at very high speed. Liquids have a little less kinetic energy as compared to the gases, and solid particles show minimum amount of kinetic energy, so they do not show much movement, they only vibrate at their own places, and that's why the particles of solid remain fixed at their place. So with this, now we have understood the three states of matter. Now here it is also important to understand how can we modulate these attributes, and is it going to affect the state of matter? By which I mean, can the state of matter be changed? Yes, it can be, which we will be discussing in our next lecture. But let me give you a very brief introduction that how can we do that. Distance between the particles can be reduced or can be modulated by changing the pressure, low or high pressure. High pressure will reduce the distance between the particles, and kinetic energy of particles can be modulated by changing the temperature. If you raise the temperature, particles will gain kinetic energy and will move about with higher speeds, and if you lower the temperature, particles will have very low kinetic energy and they will show limited movement. So if we play around with pressure and temperature, then we can certainly change the state of matter, and that is something that we will be discussing in our next lecture. Thank you.